Okay.
Okay.
So chapter 7, data decision structure. Okay. So in the chapter 5, 6, and now 7, we basically work on some more advanced structure. So chapter 5, we are on string and list, right? That's data structure. And this chapter 6, then chapter 6, we work on the functions. Okay, now we are on chapter 7, we work on the decision structure. Decision structure basically is the if and else. And if else if. These 3 different structures. Okay, let's look at that. So first, before we go ahead, there is some tool called DIA diagramming editing tool that's used to draw the flow chart, and you can download from diagrammo.com. This one, okay, that's actually you can download from there, and then you will be able to access these different flow chart tools. And right here, let me just point out a few important ones for this flow chart. First is the terminator. Terminator, actually, when you draw a flow chart, you will have something like this one, oval shaped rectangle. You will put something called star. Okay, and then you do something. When you do something, actually, you will use this process bar. Okay, and then you have the if then else. You will have if and then true or not true, and this one is false. Okay, you will have a diamond box, and the diamond box is for decision of if else selection. Okay, it's usually actually is used for those purpose. And sometimes this diamond box is also useful for while loop as well. Okay, and it's also useful for anything that need logic. Okay, for anything that need logic. Okay, and then there's a data. Data means that you key in from your keyboard or getting the data from file. So there's some process to help you. Okay, and then there's a document. So document means file or some paper you would like to print out. Okay, usually it's like a document to read in or read out. So read in you may use scanner, and then read out you may print out. You may print to printer paper. So the shape is somewhat like printer paper. Okay, and then there's a subroutine, smaller function. We will use this, and then we have this preparation display. Display actually is monitor, and then this one manual input is a little bit like car reader's card. Okay, and then other than that, these are not very important symbols, except this connector. Connector is also very important. Okay, connector is also very important. What's connector used for? For example, like there is one page that's too big, so I use a connector and I write A. And then so from somewhere else, I put an A over here and then start to do something. That means these two are connected together. So that actually is used for connector. So your flow is like this, going here and going here. Okay, but in fact, you don't need to draw that. You just need to draw the name of the connector A to A. Then it's representing that these two nodes are connected together. Is that okay so far? So this is the flow chart. So here we have some program like poly2, polynomial, second order polynomial quadratic equation, ABC, right? If A is equal to 0, okay, and then if B equals 0, then the equation is extremely degenerated, okay? And then you see here stop. And if the A is actually a not equal to 0 and B is actually not 0, that means that it's a linear equation, ax plus y equals ax plus b type of equation, right? And that degenerated one actually is only a constant. Okay, then if both A, B are not 0, then you should be able to calculate for what? For the determinant, right? And then you get the root. Okay, are you okay with quadratic function? Have you learned the quadratic function?
For
algebra 1. Say I have an equation ax plus by plus bx plus c equals what? What is the root for this guy when this guy equals 0?
oh wait.
Have you done this or no?
Wait, I think I learned this, but I'm not
Okay,
sure.
the first thing, like decrement. Do you know decrement?
Is it like putting them into two parentheses?
Decrement then equals square root b squared minus 4ac. Have you ever heard of this?
Oh, no, I haven't done that.
Okay, and the root will be, the root for this one, root 1 and root 2 for this one will be minus b plus minus square root b squared minus 4ac divided by 2a. Have you done this?
No.
Okay, so anyway, if you haven't done this, it's okay because your math had not advanced to here. But basically, this flow chart is to solve this quadratic equation. Okay, and it's used to solve quadratic equation. And the equation you see that y equals ax plus b, we call it linear. Linear means the x only has the first order x. This one's called quadratic because actually the x is up to the second order. Is that okay? Is that okay?
Yeah.
And
yeah.
how the root can be found? It's okay because you haven't learned it, but you just know that here is a flowchart to calculate this type of the quadratic function. Okay, so don't worry, we are not testing you the math. So next one is decision condition. Okay, and you have the greater than, less than. This one's less than, that's equal to, double equal means equals. Okay, single equal is used for assignment. Double equal for equality check. Okay, so this one equivalent to the mathematical equal sign.
So
Yeah, go ahead. What question?
wait, doesn't it like so it could say like a string? Could it do that?
Yes, string.
Yeah,
Yes.
yeah.
String
Okay.
yes in Python, but not in Java, not in C language.
Yeah, cause
So in Python,
yeah.
yes. In Python, yes, but not in other language. So if you learn other language, the double equal sign is not okay, but Python is okay. Greater equal and greater than, exclamation mark equal, that means not equal. Okay, usually the exclamation mark means not in many other language, and here we only have this for the relational condition to have this one not equals. Okay, and then there's a Boolean variable. A Boolean variable is a variable which has only two possible values, true or false. Okay, and then the logic operation return Boolean value will be true or false. Okay, and then you have two input and you end up with so many different logic conditions. So let's look at the example. Before we go in further to other things, let's look at the example. So what is Boolean variable and what is the relational operator? So here let's do Boolean. So I can say Boolean 1 equals 3 greater than 5. Okay, so it's Boolean 1 true or false. So Boolean 1 is a variable. We call it Boolean variable. Okay, and then Boolean 1 equals 3 greater than 5. So is Boolean 1 true or false? Hello?
Oh, sorry, false.
False. Okay.
Yeah.
So but left hand side B1 actually I call it Boolean 1. It actually is a variable. So the value depends on the right-hand side value. So the right-hand side value, we call it a relational expression. So 3 greater than 5, we call it relational expression. And sometimes we also call it Boolean expression. And now what is Boolean? Okay, what's the word Boolean? What is the word Boolean?
Relational?
No, it's actually it's not relational. It's someone called a person called George Boole. Okay, and this guy is a mathematician in the 19th century. And this guy called George Boole. And because of its name, he invented this Boolean algebra and Boolean stuff. So we say Boolean become it's a possessive term, right? And something like Euclid, right? Euclid, and then you add Euclidean is a Euclidean algorithm, Euclidean theorem. Okay, so this guy same thing is called Boole, but we add the an on it. It becomes Boolean, and then Boolean actually he invented this kind of the mathematics. Okay, differential equation, symbolic logic, basically symbolic logic. So the symbolic logic also known as Boolean algebra. And why Boolean? That's using his last name. Okay, so the Boolean algebra he actually invented. It's basically has this x and y, x and y, x or y, x and not x. Okay, so it's called Boolean. Boolean is to deal with this true or false type of things. Okay, it's to be deal with this type of true or false type of thing. So we can have a equals 3, and then b equals 4, and then we say Boolean 2 equals 4. I mean b greater than a. So this one again, the right hand side is another Boolean expression. Okay, so a variable b1 equal true or b1 equal false. We call this one as Boolean variable. Okay, and we have the this one a equals 3, b equals 4, and then b greater than a. This whole thing we call it Boolean expression, right? It's called Boolean expression. Okay, so there is a Boolean variable, there is a Boolean expression, and there is another one. If we define a function, okay, greater, and then we have x and y, right? And then return if x greater than y. So here, let's do this. We can print out this one greater of a and b. Okay, so a we will have 3, right? A you will have a value of 3 over there. B you will have value of 4. It pass through here, so 3 pass to x, 4 pass to y, and then it will return x greater than 4. So the return value will be false. Okay, so you will print now false. Okay, let's try it. Okay, let's try it. So you print out false. Okay, and this one we call it, this one greater we call it, this one we call it greater is Boolean function. So far we have Boolean variable, and then we have Boolean value. Boolean value will be true or false, right? And Boolean variable that will be assigned by a Boolean value, and then a greater than b, that is Boolean expression, and this one greater than, we call it Boolean function. Is that okay? So Boolean, same thing, you have variable, you have value, you have a function, you have expression. Is that okay?
Yeah.
Okay, so that's actually the logic condition. We have Boolean, and then the next one we need to know about something. This one is called truth table. Okay, this one is called truth table. So what is truth table? What is truth table for? Okay, let me give you some idea. What is a truth table? Okay, if we want to study like there's a boy, you know, and then he will try to find some girlfriend. Okay, there's a boy and there's a he's trying to find some girlfriend, right? And then he would define nice girlfriend. Okay, that's called the NGF. Okay, he defined nice girlfriend as his requirement for nice girlfriend will be what? Beautiful and understanding. Okay, some girls are really not reasonable. Okay, and then some girls are not ugly. Okay, either way, if not matching both of them, it's not okay for him. And usually the end we write down as end in Python. So need to be beautiful and need to be understanding. That's called this one reasonable. Okay, that's not using the word understanding. Let's call it reasonable. So here I have a variable called R. This one's B. So my nice girlfriend defined as beautiful and the what? And reasonable.
Reasonable.
So I have beautiful and reasonable, right? And then if I write 0, it actually means false. If I write 1, it actually means true. Okay, and in Python, it need to be capital F, capital T. Okay, but let's show for this. Both of them, both this girl is not beautiful and not reasonable, then nice girlfriend will be not. She will not be a nice girlfriend. Some of them is actually not beautiful, but very reasonable, still not a good girlfriend, right? And then some of them are beautiful but not reasonable, still not a good girlfriend, right? Some of them actually are both beautiful and reasonable. That's a nice girlfriend. So nice girlfriend defined as beautiful and reasonable. So need to have both. When you have a logical condition that need to have both, we call it AND. Both of them need to be true. We call it AND. So here actually, this nice girlfriend need to be beautiful and reasonable. Is that okay?
Yeah.
Okay, so that's the AND function for truth. And this whole thing we call it truth table. You list down all the condition and then figure out whether the logic is true or no. This is called truth table. Is that okay? Now let's talk about OR function. Okay, OR function. Say a person who is trying to apply for UT Austin. Okay, UT Austin admission. Okay, this condition that's called it UT. Okay, so this UT actually is this guy trying to apply it will be equal to high GPA. So let's call it G, high GPA. Or this one called or he is playing football well, right? You can't recruit it by the school because you have high GPA or you have play football well. Is that okay?
Mm-hmm.
So your UT right now, you have a high GPA and a football. If you don't have both, any one of it, UT will not accept you, right? But if you have poor GPA but good football skill, you will be admitted. If you have good GPA and no football skill, you will still be accepted. If you have both good GPA and good football skill, you will be recruited. So this one we call it OR function. So see the difference for and OR function. So if
Yeah.
you have the beautiful and reasonable and nice girlfriend, it will be. So there's only one case. It's actually meeting it. It's like both are beautiful and reasonable. And this one actually we have this one say a person whether he can be accepted by UT Austin is based on what? Based on whether
The high
one,
GPA
yeah,
or
or
football.
football. Any one of the condition would be true. Is that okay? So let's try this one. So try this one. Let's go to here, right? I'm trying to write a program for this one, but here let me try a program called this one. Let me call it UT. Okay. So here I have for loop. Okay. Here I have for loop. This one is called what? This one called high GPA for loop in. So this is a high GPA for loop will have false and true. Okay, high GPA can be false or true.
Why is it in brackets?
In bracket actually is, you remember that here I can put any list, iterable stuff over here. When we do chapter 5, you remember that one? This one is actually a list. You can put a list, you can put a range function over there. You still remember that?
Yeah.
So here I can, again, right here, I can also write football. Okay, and then I print right here. Before I print something, let me print here like okay. Let me print something like this, and then print. I print the title. Okay, 50 of the equal signs, and then here I will print like I print high GPA, and then let me actually do this. And here I say it's high GPA, and then football, and then here I put UT. Okay, so here I say UT equals high GPA or football, right? I assign the value of high GPA of football to it. And then at the end, I print out these three variables in the appropriate format. Okay, and let me see, maybe it doesn't take this one. Maybe I print S. Okay, so let's try this one. UT is not defined. Oh, I'm sorry, I miss a U. Okay, let me see. Wait, I don't need this one. Oh, I should put this one a little bit forward. So let me put this one like 7. Let's put 6. Okay, and then the middle one, then put 18. That's about it. That should be fine. Okay, and then let's run it. Okay, so high GPA, play football well, not well. Low GPA, not playing football well, will not be admitted to UT, right? Is that okay?
Yeah.
Okay, so this one is, I use the high GPA as one dimension, football as another dimension, right? Both of them are traverse through false and true. So for the first case, I would have force, high GPA force, football force, and I print it out the first line. And then when I go back to here, I change for my football to be true. So high GPA force, football to be true, and then I print out the second case. And then finish the football iteration. Go back to high GPA, and then high GPA now become true. Okay, second time. So basically, this one is like, it basically would give you like high GPA and football. You have true, false and true, false and true. The whole thing will go over like this. First case is this one. Second case, this one. Third case, this one. Fourth case, this one. And the first case, second case, third case, fourth case. Okay, and we have a function called, we have operator called OR. Now actually need to have one of the condition need to be true in order to have it to be true. Okay. Similarly, we can write another one for the nice girlfriend, but that I just omitted. You can try yourself, okay? You can try yourself, use the end function. So the next one is logic, let me see, the logic condition example. The logic detection condition example. So we have x greater equal to 0 and x less than equal 3, y greater than less than equal 4, y greater than equal to -1. So basically in your xy, it actually means x greater than 0, less than equal to 3. So the x should be right here, from here to here, right? And then y is less than 4, greater than -1, x 0 to 3. So it is this region. Okay, that region. So basically, Python support a logic operator or and, or, and not, 3 operator. Okay. Other than that, you can set up with different Boolean variable and Boolean expression to handle it. Okay. And you need to write more program, then you will know how to handle those conditions. So here we have convert to. Okay. So we enter some value, and then if it is actually greater than 90 degrees, we say it's really hot out there, be careful. If it's less than 30, we print out, be sure to dress warmly. Okay, so that is the variable. Let me open the project. Okay, open the project. And this one is over here. And let me open the Python course. Okay, this one, I have a code. Okay, chapter 7, right here, okay. So chapter 7 right here, I have this one called convert to, okay. The convert to actually the one we talk about. So here I can run it. Okay, you want me to enter some temperature. That we call 40. So you say that it's 104 degree Fahrenheit and very hot out there. So there is the if else condition, okay, and actually the process, the execution for is you get started from your function over here, right? Get function over here, and then there's the first decision whether Fahrenheit greater than 90 or not. If yes, actually we will print out this message. Okay. If not, you just go down, and then actually you ask for if f less than 30. So this one will come back to here, and if lower than 30, it actually will print now. Otherwise, you go back to here. Okay. So this left hand side is the flow chart for it. 2 branches up. Okay. Is that okay so far? Hello?
Yeah.
So this one is called Fahrenheit, okay? And for these different programs, actually I sent it to you already, okay? This is a simple program for each chapter, I actually sent it to you. So right here, you move back, I sent you the chapter 3 new version slices. I also asked you like these 2 versions, I need you to give me the name or number. So here there's a jump data code.zip. Okay, download this one. Okay, you have everything you need over here. Okay, for each chapters, whatever you see right here, the whole book I just show you. That's not demonstration. It's a book chapters example. Here the code is all 13 chapters examples. Okay, I actually upload to here. Okay, please download. Okay. Okay, download that one. And
yes.
then you unzip it, you will have all the Jiang textbooks example. I just recently compiled it, okay?
Okay. So, for those, oh, sorry.
Yeah, go ahead.
For the word problems, so do I write, how do I?
Your true or false or multiple choice problem, that is good. You have written the unit number, right? So I know that which that one is okay.
Do I write
the only problem is that you need to write in your program. So eventually when you go to college or somewhere, that is one convert too. So what you should do is that right here has a comment, right? And you say name, right? Nelson Wu, right? And then here maybe student ID. Usually in high school or college, you need to do that. And then you type your number, right? And then here maybe you also include something called version. So you type like 3.0, and then you may put 10/17/2018 in there.
Oh, okay, yeah.
Something like that. So I know that, oh, this version you written it down in yesterday, right? And who you are, and then also maybe you also can do this. You can do like a question. Okay, write something like this, a comment saying question, and here say like exercise. I'm sorry, I have one more. Let me see. 5.8, something like that. So I know that, okay, this problem is 5.8. Anyway, I received quite many files. I don't actually remember which project it is, because the name you have is like code text 1, 2, and then, or maybe you have a Shafir or something. So it's hard for me to recognize, remember which chapter's solution is that for, right? It's very hard for me actually to keep track of, okay, you are on chapter 7, because your submission sometimes is also out of order. You submit some later chapter before some some current chapter, right? So it's hard for me to track that. Okay, this one is what. So the next one is quadratic function. And because you don't know about quadratic, so let's omit this quadratic one. Quadratic 2, 3, 4. Okay, so that's 5. Let me try something else for this quadratic, okay? Because I still want to show you the if else statements. I still want to show you the if else statement. So because there is no quadratic, you don't know about a quadratic, that is fine. It's actually okay. Okay, so here let me try something called. Let me try something called one. Let me see. If else, let me try something. It's like zodiac. Okay, let me try something called zodiac. That's what I call it zodiac. Okay, so I have something here, right? So here, the first one. Let me try to get the Chinese zodiac. Sorry. The Chinese zodiac name. Oh, here is okay. Red ox, whatever. This is what I need. Okay, I just need to have those names, and then come back to here. Get it. Come back to here. Let me put it here. Okay. And then I don't need the period. I don't need the end. 09643. Sorry, every day I need to deal with this garbage call a lot.
Okay.
So here I just put the double quote there, right? So this will become the Chinese zodiac, right? Okay, horse. Horse is number 7, so it's a half. So let me cut it down here, right? And when you have a line that actually unfinished, there's an unfinished line. Okay, if there's an unfinished line, and you want to connect 2 lines together, so what should you do? Here you can have this one to connect 2 lines together.
Or slash?
Yeah, slash. It's here, okay? Let's see, okay. Let me finish this whole set, okay? And because I want red to be number 1 instead of number 0, so here I will say a empty string and then put red over there. Let me see. It's a backslash. Let me actually compile it and long it.
Oh.
Red has a 2 quote. Okay.
Yeah.
It's okay. You try, and sometimes you just like to try. Okay, this is fine, right? So that's it's a zodiac. Now I actually let me see. Actually, I need to find out. Oh, I know actually like 1800 Chinese zodiac. Okay, I need to know about some years reference. So the year 1800, I had monkey. Okay, I had monkey. So let me see. Say monkey is 9, right? So here like okay. Let me see. Z equals 9. Okay, that's for the year. That's for the year what? That's for
year, that would be.
That would be year. Let me see. It will be year 1800, right? So put the remark like 1800. Okay. So here let's do this. Define function get zodiac, right? And then I should put something called year in here, right? It's okay. And I put this G equals 9 over there, right? I put my G equals 9 over there, and then I have a year, right? I have a year. So my G will be my year minus 1800. So this one actually is what? Let me do this. This one probably too confusing for you. So like this, okay? So my 1800, I have my monkey year, right? And then if I'm 1801, then there's a 1 year after the monkey year, so you become 10, right? You become 10, right?
Yeah.
Okay, you become 10. And then if it actually is, let me see. If it actually is, let me see. So let me see. Let me actually get this one out. Okay, let me get this one out. Okay. So here, let me see. Oh, okay. Let me just put it there. Sorry. Okay. So this one actually, I would know that this G will be the G would be, say, this G will be, let me see. The G will be the zodiac from
9.
9, right? So here, let me actually take modular by 12.
So,
right?
yeah.
So actually I can have my G take modular by 12, right?
Don't.
Let me actually put the monkey as 8 instead of 9. Okay, probably this is better. Okay, and then here actually let me remove this. Okay, let me remove that empty string. So now when Z equals 0, it will be rat, right? When Z equals 1, it will be ox. And then when Z equals monkey, it should be A, right? So pig will be 11. So now actually I know about how many years after my monkeys, and then plus the monkeys year index, and take modular by 12, I will get G. Okay, and that G number actually is between, so this G will be from 0 to 11, right? So now I'll do like, say if G equals 0, return what? Return zodiac of G, of 0, okay? Return zodiac of 0, and I can actually copy this one. And else if, okay? And this one is, if it's 1, I return the zodiac 1, right? So then I copy.
Oh, and then to the 2, 3, 4.
Yeah, to the 2, 3, 4.
With the percentage equals, what does that do again?
Percentage equal taking modular, the remainder.
Oh, yeah. Okay.
It will be taking the remainder, okay?
Wait, then why would it like remainder 12?
Because every 12 year you take a circle, take a repeat the same. Every 12 year we repeat the same zodiac. So year 13 is the same with year 1, right?
Oh, yeah, okay.
You know what I'm saying? You know what I'm saying?
Mm-hmm.
And why is that?
Oh, because
why year 13 is actually the same as year 1?
Because it's a cycle.
Yeah, I know it's a cycle, but when the Chinese people invented the Chinese zodiac, what are they based on?
Animals?
No.
The race?
Animal is only a name. Okay, animal is only a name. They based on the Jupiter. They based on where the Jupiter is.
Oh, I didn't know that.
Jupiter go around the sun every 12 years. So you cut the whole orbit into 12 parts. So if you see a Jupiter over here, say let's say it's a red year for one, right? And here pink year over here, right? You just look at where the Jupiter is, and then because Earth also go around the sun, Earth is like this. So you can see here, but you see that it's Jupiter is on red side, or you see maybe Jupiter is over here in the dark region, right? So that's how they come out with the this zodiac. Is that okay?
Oh, yeah. I thought they did some sort of like animal race.
That's the story.
Yeah, the story.
That's
Yeah.
a make-up story. That's a make-up story. Actually, it is not. It's just a make-up story. Actually, it's not real.
It's like the those tails, right?
Yeah, I know. There's a race, but to be honest, nobody actually see the dragon before.
Yeah.
So they can have such a race. Okay, they can
Yeah.
have such a race, but we don't need a 12 one. Okay, so that's what it is here, right? So we have this if else is Elvis. So the last one actually you can also put else. That actually is fine. Okay, you can put else. That actually is fine.
Oh yeah.
Okay, because you have different value, and then you actually will take modular by 12, so you won't have difference, and then every time you just return it. So last one you can have else, and in fact you can also have delete the else. That's also fine, because whatever have been returned is done already. So you can just put a default case is the same as you put an else. So let's put an else for the time being, and in fact that else is also redundant. Is that okay?
Mm-hmm.
So that else is also redundant. Okay, and then actually this one, let's do this. So let's start it from like 2000, like 2021. Okay, and then we do what? Get print now our year and the space, and here we have year Is that okay?
Yeah.
You every time you get a year and then get the zodiac of that year and then print out the data. So 2000 should be dragon year, okay? 2000 dragon year, and then like that, okay? And this one actually I'm using the if else one, right? But in fact this is a little bit overkill, okay? And if you are smart enough, actually you can just do this. Okay, you can just do this, and then you can copy this one actually. See, you can copy this one up to here, right? And then you actually can do this one is actually plus equal, and the original G is actually 8, so the first line can be deleted. Okay, and then the whole thing right here, you can actually do, actually also you don't need to press it, okay, and you can just do the whole thing 10 modular by 12, Okay, so this line can also be removed. And after that, you can further, because it's already the Z you want to have, right? So basically you can cut this one over. And then here, because the original value is actually a zodiac, so you can actually do zodiac. And then put that expression over here. And this is done. You don't need to call the function. You can just do this. You will get the same result. Okay, I just teach you what the if else if, right? But if you really want to actually do smart job, this single list access scheme will be way faster. And of course, you need to spend some time to understand what's going on. The year you have minus 1800 plus A, the total number of a year from the 1800, 10 modular by 12, right? You get your zodiac index, and then from the zodiac index, you search for the zodiac you have, right? And this one is the same if you call the get zodiac using the if else if. So this else if is called else if. It's a new condition. So you list down all the possible conditions. But in fact, that one you can actually just do this one. That would be fine. Is that okay?
Yeah.
So this one actually, I just show you the use of else if. Okay, but because you basically you actually don't know about quadratic functions, so that actually I do this. Okay. So here, let me actually draw another diagram for you. You basically have, in Python, you have, let me see. In Python, you have the, in Python, you have if something, right? And you semicolon, and you do something here, right? So that one actually just do this. And if not, you go back to here, okay? Second one, you have if something and then else something. It actually is, if you have true, you will go here. False, you will go here. So this one we call one-way if. This one we call it two-way if. So there's an if and there's an else part, right? And then we can also have like this as one way and two way. We have multiple way of if. So the multiple way of if is we use this one, if, right? Z equals 0, and we do this. If, else if Z equals 1, we do this. Else if Z equals 2, we do this, something like that, until you have an else. Right? So it actually is, there's a big decision. Case 1, do this. Case 2, you do this. Case 3, you do this. Case 4, you do this. Case 5, you do this. And these are the multiple if, multiple way of the if. It's okay? This one is called multiple way of if. Is that okay? Hello? Are you all right?
Yeah. Sorry.
Okay, that's the multiple way if. Okay. So let's go back to the screen. We finish that, and then here we have something. It actually has something called error event handler. Okay. So let me actually teach you this try except. Okay, teach you try except since the textbook had that. Let me actually teach you how to do try except. Okay. And let me call it input validation. Okay, let's call this file called input validation. So there are times that you want people to enter some value, and then actually you will do some processing, right? You'll do some processing. So here, that means let's say that you want to calculate the square root of something. Okay, so you have some data you call floating point, and you say float, right? And then you have input, and you say enter, right? For real number, okay, and these real numbers should be positive. Okay, enter positive real number, right? And then you actually print out, right? Mass.sqrt of f, square root of f, right? Let me delete the mass, see if it works. No, we need a mass library. So here I need to first import the mass. Okay, from mass library I import the mass, and then I ask for some value, and then see if it's actually print the mass square root of it. Okay, so this is some simple program. So I actually print it. Okay, and then here actually enter a real number. I say 9.0. That's fine. Okay, that actually taking the square root correctly. So if I actually here input validation, I enter a number minus 67. Oh, it's not okay. It is a mass domain error. It's a value error. Okay, it's a value error, mass domain error. Okay, and then let me try again. If I actually put in some number, I type A, B, C, D, whatever. Oh no, this one is value error. Okay, so that's not allowed. But I don't want my program to fail, right? So here, let me put here, say something called done equals false. Okay, and then while not done. Okay, so this is a Boolean condition.
Oh wait,
you did this?
there's a while not done.
No, there's not done. Not is a variable, is a operator. So actually here it will happen like there's no while not done. It's actually this not is an operator.
So it's while.
Put a false and then not false, it will become true. Right? And if the done is equals true, it will be not true, and that will become false. So while not done, we will do this. If somewhere we say done equals true, then the loop will not continue. Is that okay?
Yeah.
Is that okay?
Yeah.
So here while not done, we will actually continue to ask for this, right? So here I'll say try, okay. And then I input some f, okay. And here I'll say if f less than 0, and I'll raise 1. Here I'll raise a string. I raise a string. I'll say something called negative input. Okay. And then here I'll say done equals true. Okay. And then if not, here I'll say except. And then here I have a string. And here I'll say print. Okay. And here I'll have another one called except.
Oh, you spelled negative wrong.
Okay, it's okay. I'll come back to change it. Okay. This, right? If there's a value error, then I'll print wrong data format. Okay, so right here we have a if else, right? If else right here, right? So if my f less than 0, so here actually is the program will be like this. We do this, we go into the while down, and then we come to here, right? And then we get the data for floating point. If the floating point less than 0, then we raise actually is signaling there's an error. Signaling there is an error. So it will not continue to do these two. No, it will not continue. And you will do what? You jump to from here, since it raised negative input, you will jump to the negative input and then print out this negative input. And then because down it has not been set to true, so you will look back, come back to here to do reading again. Okay. So, but if the data is not a 14-point number, in the case that the data is not 14-point number, you go here, it's not 14-point number, so you try to take the square root, it will have error, and you will go to a value error part. Same thing, you put out wrong data format and come back to SU to enter new data again. So that's wrong this one. Okay, that's wrong this one. So here, let me just type garbage. Catch that did not inherited from base. So here, let me do this. Here it should be. Let me do raise base exception. Okay, let's try this one. Okay, so here I should have base exception. Now let me see. Let me actually get this out. Okay. Let me cut this one. Okay. And put it here. Let me just raise. Don't raise this. Let me see. Let me see what it is there. There's an object is set. Oh, there's a as object. Okay, there's a as object. You need to have a as object. So here you need to have as e. Okay, as e is fine. Okay. So here, let me see. So here, okay. And here, I should also have the base section as E. Okay, let me see. So here, let me type garbage. Okay, and it actually catch by this, say wrong data format, right? And you go back to XU to type in some data, right? So this time, let me do minus 3.4. It will say negative input. Is that okay? So here I raise some base exception, and the base exception will be deal with by here. If it's wrong because you have f less than 0, you go to here and I will say print out negative input. But after I print out negative input, my down original is false. I have not done yet. So I go back to here, check if my down is done, and it's not done yet. So I go into this try portion again, and I enter another number. And if it actually is greater than equal to 0, and also it can be taken square root, then it will go out and finish. So here, let me try 5.6. You go out, print out the data, and then get out. If it is garbage or it is the negative number, you will have different case to handle with it. So we call this function, all this program as input validation, to make sure that when some people enter the data into your program, you can actually take care of it. And this thing is called try except or try catch block. What is try except? This one actually is, the loop is like, I put my code over here, right? So I try this code block. If everything is fine, I will get out and done. If not okay, something wrong, you will go into the exception, except something, and we will see what kind of error it is, okay? It is a value error, you will do this too. If it is a base exception error that we raised here is a negative input base exception, we'll do the other one. So basically, if there's something wrong in the program right here, and you will go ahead, jump to the exception. If nothing wrong, we will continue to finish the whole section, and we will have done equal to, and then we will get out from the whole while loop and get out. And in that case, you'll go directly out and get out. It's okay so far? So far for this input validation portion? Yeah? So
Yeah.
that's the input validation. So because you don't have a quadratic, so I don't want to look into that, okay? And the next one is like maximum number of 3, right? So here we have 3 ways of doing that. The easiest way is that I just call a Python function. There's a Python messed up function. Let me see if there's a code. Okay, there's a max n code, okay? So if there is a Python function, you can do that. Otherwise, you can do this. Okay, you can do this. And then, or you can do this. Okay, let's actually go to Python, this one. So here, let me try this one called max 3. Okay, 3 input maximum. So here, let me see, we can have a value A equals 3 equals 5, C equals 2, okay? And then here I can have a max A, B, C. This is the easier way. Call Python max function, okay? That's the easier one. And then we can print. That is one easier way to print now the maximum of 3, okay? That's fine. Second way is, okay, second way is like, let me assign the max equals A, right? And then I continue to compare. If B greater than A, then max equals B, right? Or C equals, let me say, no, B greater than max, then I say max equals B. Or C greater than max, then max equals C. Okay, and then this one, print my max. Okay, and that we should get the same value. That's a 3-way to do it. And then here, there's another way to write it over here, okay? Compare each to all. Okay, I don't think whether this one will work or not. I'm not sure. I'm not sure whether this one will work or not. I'm not sure whether this will work or not. Oh, this one actually is okay. It actually not in Python language. This one is actually okay. Okay, so let's try here I can do max. Okay. So here I can have like, I'm comparing, right? So if A greater than B and B greater than C, greater equal than C, then I have the max equals A. So the same thing I can make copy, right? So I have this one, change the order of A and B, right? And I can copy 1, 2, right? And the middle one I set to B. Last one I set to C, right? And here I can have like B, B, and then A swap with B, right? And now here let me swap A and C. Is that okay? That's another way to calculate the maximum value. Okay, and there's another one. There's another one to find out the maximum. Here I have max equals A. Let me do this. Let me do this. Okay, let me do this. Let me do dist. Dist. Let me say S. S equals A, B, and C. Okay, I put my ABC in there, and I say for I in range. Here I say max equals S 0. Okay, that would be A. Okay, and in range of length of length of S. Okay, and this time I have like if I S of I greater than max, then max equals S of I. Okay, and in the end I print out my max. Okay, that's another way to write it. Okay, that's another way to write it. And then I can also write another way called max equals some huge number. I'm sorry, some negative huge number. Okay, and for what? For x in my s. Okay, if x greater than max, right, and max equals x. Okay, and at the end we print now max. So this one is also finding the max among the ABC different number. So how many versions here? How many versions we have here?
How many? What?
How many versions of finding the maximum?
2.
No, we have quite many versions already.
Oh, sorry.
Are you okay?
Yeah. Oh, sorry. Yeah.
Second version.
It's like
Third version. We have 5 versions over here. Okay, we totally have 5 versions of code.
yeah.
This one should be greater than, okay. Okay, the 5 version will similarly. Is that okay? So the first version we use a function from Python. Second version we use the setting the maximum and then serially checking each one whether it's greater than maximum or not, right? And then the next one we use the 3-way comparison to find out the max, right? And then this one actually we use the traversing through the whole array using the index, and then using the index to compare the maximum. And the last one is that we compare each element what is greater than a default condition or not. Okay, so that's the whole different way of figuring out the maximum among 3 number or more number. Okay, and this is only one of the examples, so I just pass it. Okay, so this chapter work on 5A and 11, please, and all the true and false and multiple choices. Is that okay? Any question for today? Is that okay?
Yeah. Mm-hmm.
Okay, thank you. Bye now.
Okay, thank you. Bye.
Bye-bye.